30, 60, and 90. X, 2x, and x, root 3 for the 30, 60, and 90. 2x is the longest side. I just had to make it rhyme. Longest side is the hypotenuse. Now we can introduce x and x and x, root 2, congruent sides. We got 2. X, x, and x, root 2, congruent sides. We got 2. 45, 45, 90. And isosceles righty. X root 2 is the hypotenuse. Those used to be obtuse.
Hey guys, and here is the second section of Unit 9. So we're going to be taking a look at special right triangles with trigonometry. So as for a quick review, there was that video, that little jingle shindig. And so if you have not memorized your 30, 60, 90, and 45, 45, 90 triangles, now is probably a good time. If you need some help memorizing it, just rewatch the first 40 seconds of this video, like over and over and over again, and then you'll be just saying x and x and x2, on and on and on. And so you'll get it. So 9.2 has two objectives. Given a special right triangle, I can find sine A, cosine A, and tangent A. And the second one is I can use trig ratios to find the missing side length. All right. So we have been looking at three trigonometric ratios of a right triangle with an acute angle, and they are defined by ratios of two sides of a triangle, whether the sides are the side opposite the acute angle, whether the sides are adjacent to the acute angle, or whether it's the hypotenuse of the triangle. So the trig functions are sine, cosine, and tangent. Remembering SOHCAHTOA, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we were looking at theta, this is a common Greek symbol that is used for angle measures. So if we have theta, sine of theta would be opposite over hypotenuse, or 4/5. Cosine is adjacent over hypotenuse, so 3/5. And tangent is opposite over adjacent, so it's 4/3. So let's take a look at our 45, 45, 90 triangle. So consider an isosceles right triangle with two sides of length 1. If we wanted to find the third side, we can either know our trig ratios are 1, 1, and 1 rad 2, or we could do 1 squared plus 1 squared equals c squared. So 1 plus 1 equals c squared, or the square root of 2, so that this is the square root of 2. Okay, so let's calculate what sine, cosine, and tangent 45 is, given that a 45-degree angle would come from a 45, 45, 90 triangle. So sine 45 is opposite over hypotenuse, or 1 over radical 2. But remember, back from Unit 8, we can't have a radical in the denominator. We need to rationalize the denominator by multiplying root 2 over root 2. And so we get a special form of 1. And so we get root 2 over 2 as our final answer. Tangent 45 is opposite over adjacent, so 1 over 1, which equals 1. And cosine 45 is adjacent over hypotenuse, which is 1 over radical 2, or radical 2 over 2. It's a good idea to memorize these three numbers, that sine 45 is radical 2 over 2, tangent 45 is 1, and cosine 45 is radical 2 over 2. If we don't memorize it, at the very minimum, we should memorize our 45, 45, 90, the ratio of the sides of 45, 45, 90 triangles, so that we can then easily find sine, cosine, and tangent 45. All right, so now let's take a look at 30, 60, 90 triangles. So consider an equilateral triangle with each side length of 2. And the three sides are equal, so the angle measures are all 60 degrees. And, yep, there we go. And the perpendicular bisector of the base bisects the opposite angle. So where is my mouse? There we go. So the perpendicular bisector, so that makes these two congruent, and that this is perpendicular, bisects the opposite angle. So now we have two 30-degree angles and a 60-degree angle, and then two 90-degree angles. So this creates a 30, 60, 90 triangle. So this third side, using the Pythagorean theorem, that 2 squared minus 1 squared is going to equal 3. And so this is going to be the length of square root of 3. So the ratio of side lengths is 1 radical 3, 2, or 1, 2 radical 3. So sine 30 is opposite over hypotenuse, so 1/2, 1 over 2. Tangent is 1 over square root 3, opposite over adjacent. Or after we multiply by a special form of 1, square root 3 over square root 3, we get square root 3 over 3. And cosine is adjacent over hypotenuse, which is square root 3 over 2. So now let's take a look at it if it's 60 degrees. So remember, across from the 60-degree angle is radical 3. So sine is going to be opposite over hypotenuse, so radical 3 over 2. Tangent is going to be opposite over adjacent, so radical 3 over 1, or just simply radical 3. And then cosine is adjacent over hypotenuse, so 1/2. So then now we can use special right triangles to write cosine 30 as a fraction. So we know that cosine 30 would be s root 3 over 2s, adjacent over hypotenuse. And then we can simplify that to root 3 over 2. So if we see a 30-degree angle, we know that the ratio of the adjacent side to the hypotenuse of that right triangle is going to have the ratio of root 3 over 2. And we can do the same for 45, 45, 90 triangles. Let's say we wanted to write tan 45 as a fraction. Tan 45 would be s over s, because we know that these two sides are congruent to each other. And a number over itself is going to equal 1. And that is all. Please go on and take the online quiz, and then we will continue working on our application packet in class. Have a good one, guys. Bye-bye.